Hello everyone, welcome back to the channel uLearn Education Online. We are going to see the concept ideal inverting amplifier. In this video, you will get the answers of what is inverting amplifier, how it is used in ideal inverting amplifier, and how to derive the closed loop gain of ideal inverting amplifier, and why it is called as phase inverter or a sign changer. The first application using operational amplifier we are going to see is amplifier application. So amplifier application means the operational amplifier should always be used in closed loop configuration. What do you mean by closed loop configuration? The closed loop is nothing but a feedback path should be present in the circuit. Feedback path is nothing but there should be a connection between output to the input via using a passive element or an active element. As you seen from this circuit, there is a connection between output to input using a passive element, that is resistor R. Here we can call this as a feedback resistor. Why? Because we are providing a feedback path from output to input. Okay, so inverting amplifier in the sense the input signal is applied to the inverting terminal of op amp in closed loop configuration. That is called inverting amplifier. And ideal inverting amplifier means the inverting amplifier for the circuit the op amp user should be having ideal characteristics. Now what are the ideal characteristics? Some of the ideal characteristics of operational amplifier are input resistance should be infinite, output impedance should be 0, the gain of an op amp is infinite, and the bias current and offset currents, offset voltage are 0. As you seen, the bias current, that is IB value is equal to 0, nothing but 0 currents are enter at the ideal terminals of op amp. Okay, so from the circuit we can write that the node voltage at the non-inverting terminal is 0, and since we are considering the ideal op amp, for the ideal op amp we can apply the virtual ground concept. What do you mean by virtual ground concept? In brief, the virtual ground concept is nothing but the node voltages present at inverting terminal and non-inverting terminal are equal. Means here I consider that the node voltage at the inverting terminal is VA and the node voltage at the non-inverting terminal is VB. By using the virtual ground concept, we can write VA is equal to VB. Since VB is connected to ground, nothing but 0 potential, from the virtual ground concept, we can write VA as 0. Okay, so VA as 0 and VB as 0. Now from this circuit, we have to find what is the output voltage of inverting amplifier using ideal op amp. For this purpose, what we have to do is at the node voltage of inverting amplifier or at node A, simply apply KCL, nothing but Kirchhoff current law. Since the current entering at node A is I and the current leaving at node A is I1 and IB, from the KCL we can write the algebraic sum of entering currents at a node is equal to the algebraic sum of leaving currents from that node. So simply by applying KCL at node A, we can write I as I1 plus IB. Since IB is 0, we can write I as I1. Means whatever the current that is flowing through the resistor R1 is the same current that is flowing through the resistor RF. Okay, from this circuit, we can define the values of I and I1 as, we can write the equation I as VI minus VA by R1. Okay, so VI minus VA by R1. Since VA is 0, we can write I as VI by R1. Similarly, if you write the equation for the current I1, nothing but the flowing through the feedback resistor RF, I1 we can write as VA minus V0 by RF. Now what is the value of VA? It is 0. So the I1 value is minus V0 by RF. From this basic equation, simply substitute what is the value of I and I1. We know that IB is 0. From 1 we can say that Vi by R1 is equal to minus V0 by Rf. So finally the output voltage V0 we can write as minus of Rf by R1 into Vi. From this, for the ideal inverting amplifier, the gain, closed loop gain we can write as, or we can define as ratio of output voltage to the input voltage. So the closed loop gain is nothing but ACL is equal to V0 by Vi, which is equal to minus Rf by R1. So this is the closed loop gain of inverting amplifier using ideal op amp. Now for the single input, with the use of two resistors, that is feedback resistor RF and the source resistor, it is named as R1, we have seen how to derive the closed loop gain of inverting amplifier. Now we are going to see why it is called as phase inverter, okay, or a sign changer or a phase inverter. From this closed loop equation, nothing but minus Rf by R1. If you see the Rf and R1 values are equal, then we can write that the closed loop gain is nothing but minus 1. So which implies the output voltage V0 is equal to the input voltage Vi with a sign change, that is negative. Means the magnitudes of output voltage and the input voltage are equal, but here the negative sign indicates that there is a phase shift of value 180 degrees between the input and output. Because of this, it is called as a phase inverter. The inverting amplifier should be called as a phase inverter when the feedback resistance Rf and R1 are equal. If you observe the waveforms, how it is generating a phase shift. So for this, this is the input signal. Okay, so this is the input signal applied to inverting amplifier using ideal op amp. The output signal looks like having a 180 degrees phase shift. Similarly, for this input signal, the output signal looks like. This is the brief explanation of ideal inverting amplifier circuit using operational amplifier with the single input.